Houston, we have a problem. I have a problem. A bearing problem. The wheel bearing inside is making a crunchy sound. I'm gonna take you off the tripod. Listen to it. I'm gonna spin the wheel. It's quiet, but it shouldn't be making any noise like this. And of course it's not the brakes, because the brakes are dangling here on this stylish shoestring here on both sides. It's very easy to replace those bearings. In this video I'll show you how. First off, to make sure it is actually the bearing and isn't the brake and whatever, you can see my plates and everything is very clean in the brake, so it's also disconnected. Very straightforward. You can do this. 2 bolts from that side, 2 bolts from the other, 12mm socket. Very simple. Then you need to loosen the axle clamp bolt, this one and this one, 6mm Allen key or hex key, just like that. Very straightforward, yes? Once you do that, then you're gonna need this big one, which is a 22mm socket for this axle, and it's on a long, like a really long breaker bar there. And I did it all by myself, meaning I don't need a helper or anything. And then the motorcycle now is propped up, just not even, I can't even put my finger properly under on this stylish 2007 model Douglas fir stick here. That's probably part of a Christmas tree or some such thing. And then I can diagnose my bearing that is making this crunchy noise. It is faint, alright, but when I drive along other cars, the sound echoing from the cars, I can hear it. It's crunchy. It's echoing, you know, when you go by a wall or go in a tunnel or whatever. So it's fairly easy to pick it up. So from here it's very straightforward. I'm gonna have the axle stand here. I'm gonna take out the axle, take out the wheel, put the axle back in, put the bike on the axle stand, and then tap out, or yeah, not tapping as in thread cutting, but tap out as in hammer and a stick, somewhat like this, just metal, will actually tap out the bearings. No special tools needed. This is gonna be done as cheaply as possible. A top of the line bearing for this wheel is $20 on one side and $20 on the other side from SKF. The bearings, the Kawasaki dealer stocks is NTN bearing, also made in Japan, but probably that's what failed. There is exactly 36,720 kilometers on this motorcycle, so it's not surprising that it failed, but it probably shouldn't have if it was SKF. So top of the line bearing, it just cost me $20 at a bearing supplier, not going for the NTM bearing that the dealer stocks, that's shrink wrapped with a Kawasaki sticker. I'll show you. This is how the same bearing looks like in its original Kawasaki shrink wrap packaging. It's made by NTN, but it's, I don't know if you can see the letters depending on there, NTN, depending on how I pull the plastic. So there, this is the bearing that was in the hub. So this is the bearing that you need. This is how it looks like. And what's important is this 4-digit number, 6005. That's the size of the bearing that fits this hub for the outside and this axle for the inside of the bearing. Okay, 6005 is critical. The other numbers are nice to have, but they are not critical. They are garnish. Okay, then what those mean, typically you can look it up on SKF's website to your heart's content. The short of it is that you make sure that the bearing is sealed on both sides. So you see this rubber, black rubber thingy, that's the seal. Okay, so the bearing roller elements, the steel balls and the cage and the grease is not exposed, not visible. Okay, so that's what's meant by sealed bearing. That's what you need. And I want to show you one more thing. It's not only making noise, it also has a play. And for this, I'm just going to pull you just a little further back so you have full view of this. Okay, a play side to side this way. When I shake the wheel a little bit, you will not be able to see it because it's about a millimeter here at the rim. I can move this wheel without turning the steering, okay? About a millimeter. So that's bad. I can hold onto the steering with one hand, and I move it, and it's not good. It's not good. There shouldn't be any amount of sideways play. Okay, it's very, very subtle. So the first thing that tipped me off was vague feeling in steering and braking, but just slightly. And the noise when I was driving by other vehicles and or walls, and don't want that stick to fall out, and that noise the bearing made, echoing and or reverberating. So I'm going to take out this axle now and put this whole thing on an axle stand. Let's see if we can avoid dropping the bike. There, so far so good. This stick doesn't reach anymore because you can't see it from there, but come over here. I've got this stand under the bike, just gently lifting there, okay, without cracking the engine. Ideally, what we do now is take out the front wheel like so. It takes exactly this much effort, and you get exactly this dirty. Basically, none, or barely none. We'll go for barely none is a word now. Okay. Now the tripod is in the way. There. Good. The wheel is out. Put the axle back. We'll call it close enough. Now when you put this back together, these two sides now move independently, so you're going to have to, whichever side will be more weight on, you're going to have to make it work. I like putting the axle all the way in, just to maybe not clean the thread with it in the lower fork bracket with the axle's thread, but it's gonna make it easier to go back together if it's clean. So that's close enough. And with this crank, I'm gonna lower the front of the motorcycle just like so. Yeah, done. So it's staying like this now, and we can focus on the bearing. So this is a spacer, comes out, needs to be cleaned, re-greased and everything. This is a spacer, needs to be cleaned, re-greased, whatever. They are identical, so it doesn't matter which side goes where. This is a dust seal in the middle of the wheel here. I might need this one from the dealer. And then underneath that orange thing is the bearing, which is sealed. The orange part is what was black on this one. Let me show you the interaction between this spacer and this seal. This is how the cleaned up spacer looks like, and you can see that it's got some wear pattern on it. The shiny part here, that was past the seal and inside this wheel hub space, because this was again there. So you can see where the edge of this seal left a mark on this spacer there. So this triple groove here, upper, middle, lower, that's left there by the edge of this seal here. So you could argue that you may want to throw both away, or you may want to replace both. Reason for replacement: they're both now smaller. You can see that its surface where the seal contacted the spacer is pitted, and chunks of metal is missing from it there. And the same can be said about this. Is although a rubber surface, but it had grease on it. The grease caught some tiny particles of dirt and stones, got embedded in it, and those wore away the metal, as well as it wore away some of the seal. So it's not sealing perfectly. There is a 0.5 millimeter gap between the two of them. So you could say both of them are garbage, or you can save both of them and keep using them. They are reusable. The axle is resting on the bearing, so this spacer is really just a spacer, and the function of the seal is to keep the rain from getting into the seal, from getting into the bearing, so the bearing rolling elements don't seize up, which this one did. So if you want to keep the spacer and the seal, then this is what you do. You remove this seal with the bearing that you're removing from the inside. Very straightforward. I'll show you. I'm gonna keep this spacer. I'll work around this thing. And behind the bearing there is a, we'll call it another spacer, a spacer bar that moves like so, moves up, moves down. You can see it can be aligned in such a way that the axle wouldn't go through. The axle would hit the edge of this spacer, so that's important for later assembly, because this spacer here moves quite a bit inside. It can be moved to this side, it can be moved to the other side. You can move it to one side and hit the corner of the bearing. How do I shoot this? Hit the corner of this bearing here, where you move the spacer out of the way. So now here the edge of the bearing is exposed, and with a long steel bar you can tap this corner of the bearing, then move the spacer to the other side, tap that corner of this bearing, and then tap it here again, and so you can advance it out. And if the bearing pushes this seal in front of it, this seal will come out without any warps and dents or bends in it, because there is a metal component to it. The rubber is kind of work together with that metal, so there's a metal base plate behind that rubber seal. So I'm going to take this bearing out by tapping it a little bit, left side, right side, left side, right side, back and forth. The spacer is also visible inside the hub, and you won't see a whole lot. You will see the spacer in the middle. It's dark, and if you reach through with your hands through these cutouts in the hub, these cutouts are made to make the hub and wheel assembly whole thing way less. So that spacer is important also for assembly. The bearing is seated in position when it doesn't compress this spacer bar any more than this. Okay, so the distance between the two bearings on left and right sides is fixed and is set by the length of the spacer behind. Very straightforward. On the floor here we have a deluxe bearing removal station here, made out of 4 sticks of wood. Really high tech. The purpose of these 4 sticks placed close together is to support the weight of the wheel while the bearing is being driven, because you really don't want to bend the brake rotor. Okay, so there, some setup so it balances. Next thing to do, of course, is grab your bearing removal tool, which is in this case a piece of board the welders left behind, or sorry, metal fabricators. Place it in there, shift it to one side so it's catching the edge of the bearing, and have a cutesy little hammer like this, and just one tap at a time. Now the other side, I shifted this bar to the other side, and then check your progress, because you want to make sure that the bearing advances neatly and evenly on both sides. Now after 2 taps the progress is obvious, but it's not spectacular. The spacer bar moves a lot more and a lot easier now. There, that's the progress. You can see the spacer bar there. Okay, it has become a lot looser because this bearing moved this way 0.5 millimeter. We're making good progress now, and the bearing is coming out evenly. It's now almost touching the inner side of this seal here, and the spacer bar is totally loose. I can show you this way. Okay, there is a 2 millimeter gap now between the end of the spacer bar and the edge of the inner edge of the bearing. It's not spectacular, but it's obvious. So check your progress after every 2 or every 4 taps. Okay, I can't emphasize it enough. Make sure the bearing is advancing evenly, because if you bend the seat on the hub in which the bearing is mounted and you turn the bearing across, that would be a really bad situation. You're gonna need a new hub, and that's expensive. The seal popped out. This is how it looks like. Made a little bit of mess on the floor, but this is dry stuff. You can see it used to be lubricated, but now it's all dried out, saturated with dirt, and it's clumpy. So that was the outside, and the 3 streaks on the spacer, you can see that the edge here were caused by this seal. You can see that the edge here is higher as well as here, and it has a lower midsection there, so that's why 3 scratch marks were left on the spacer. Alright, so that's good to go for washing. And of course this is how the bearing looks like. It's advancing neatly and evenly, and if I haven't mentioned it, make sure you advance it neatly and evenly so that you don't enlarge and deform this part of the hub where the bearing should fit back. It is held in there by friction, and a friction should be a light force friction like this. So you know, when you put a USB into a socket, that's a light snap friction fit, and this is a light tapping fit, or a light force fit. Okay, so if you change the dimension of this part of the hub where the bearing is seated, then it's gonna be going in and out easier. You changed it to a snap fit, it's a problem. This rod I'm using is deforming at its corners in the meanwhile, as it's hitting the hardened bearing surface, and that's fine. This is a sacrificial rod, and because mild steel such as this deforms when it is forced against hardened steel, that's why you shouldn't use the spacer that's inside for removing the bearing once this one pops out. And one more thing, if you can't get this bearing removal started on one side because the tool slips off it and it falls through the middle, then you just flip it around, of course, and you try it on the opposite side. One of the sides will work, and on one of the sides this will catch on. So from here on, removal is fairly straightforward. I am checking my progress at every 2 taps. Yeah, coming along nicely. It's nice and flush. So now the bearing is flush with the edge of the hub. That's good. And you have to allow enough time for this. Just pretend you have days just for this. It's gonna come out within 10 minutes, but don't rush yourself. If you have 10 minutes only or whatever, you know, go to the washroom, eat a breakfast or whatever before you do this. Make sure you can concentrate and place roughly equal size blows. You can see the bearing is now out of the hub. Roughly equal size blows on left side and right side. Okay, just pretend you're a millionaire with time. You see, it's coming nicely and evenly. Alright. When the bearing is out, like now, then the spacer also comes out, like so. So that was the spacer that was inside the hub, and this is how the bearing looks like. Dirty, that's one thing, and dirty, that's one thing. But I'm gonna take out the seals, and I'm gonna, yeah, it's very jerky when it rolls. It rolls roughly and unevenly. So I'm gonna clean it, and we'll show you that it actually failed, because it doesn't look failed, it feels failed, and I can't really show feel on a video. Okay, now the other bearing, yeah, let's take a look at this one. The other bearing, of course, needs to come out. So this is how the space in the hub looks like. There, it should not be deformed by rotating the bearing in it any amount. Okay, very important. It needs to be cleaned with a lacquer thinner or solvent or something, so that its dimensions are restored to the original specs, meaning dirt is not making the diameter smaller. So the other bearing now comes out easily, pushing the seal in front of it that I want to save, and just use the same rod, and do not use this for any, like it's tempting and whatever. Don't. This is going to deform. Okay, just leave it alone. Wash it, clean it, put it back together. Its function is to be a spacer, not to be a strike tool. Okay, just finished cleaning up this spacer bar that was in the middle of the hub, and of course now it's obvious it's made of aluminum, so it's extra soft, but like I said, its function is to keep its length intact. So I noticed that its surface is not flawless. There are some tool marks on it. So this is on the outside, this is inside the hub, and through the hub here you can reach it. So I don't know what caused this, at what point. It isn't the bearing remover, because the my tapping bar can only possibly make marks on the inside of it, and you can see a few scratch marks there. These scratch marks don't matter much, because the axle in this is quite loose. The axle is resting on the bearing, okay, not on this one. So this is just to cover the axle and to keep the distance between the axle. So its length is super critical, its surface qualities aren't. Let's take a look at the space here for the in the hub for the bearing. This is how it looks like when it is cleaned up. And the hub is also made of aluminum, so it deforms quickly, so you be very careful with it. Okay, now I need to remove one more bearing. Same procedure. This is the inside of the hub. You're looking through the hub from one side to another. This is the bearing on the opposite side still to be removed, and you can see without the spacer bar in this hub that there is enough edge of the bearing exposed, so it's easy to find it and tap it out. So I'm gonna do that over here. Same setup as before, 4 sticks, and it's really easy to finish it from here, just like so. There. Same procedure, one tap at a time on one side, one on the other, checking progress, make sure it's dislodged and moves evenly. This is the side of the hub from which the second set of bearing was removed, and this bearing did not fail. The bearing on the opposite side failed. Reason for failure: corrosion. Corrosion caused by water. And that water leaves a mark, but not on this side. Look at the surface finish on this side here. There's very little corrosion. There's just a little bit there and a few speckles there. Very little corrosion. Overall, the surface here looks pretty intact. If I spin around this hub, just give me a sec, the other side looks vastly differently, and this is after cleaning up with lacquer thinner. You can see way more corrosion on that part, as well as on this part of the bearing, as well as on the sidewall of the bearing, as well as you can see a ring of corrosion halfway through the depth of this cutout in the hub, and that ring of corrosion goes all around. The hub is not corroded, or not corroded deeply or severely. It's the steel that's corroded in the bearing and leaves corrosion deposits and marks on the aluminum. They interact a little bit, but the aluminum isn't compromised by this. It's the bearing that failed, the bearing that stopped rolling. Over here I have these two bearings, and you can see that indeed this is NTM bearing, and I'm gonna take it apart and wash it clean, and you'll see that this one with the heavier corrosion along its outside as well as along its edge, this is the failed one. And how this rolls is, I know you can't see jerky motion, but that's how it feels. It feels seized and doesn't roll smoothly. This one has a lot less corrosion on the outer surface as well as on its edge. You can see it's completely different. There's that one spot that corresponded to that one spot on the hub, whereas this one has, again, just corrosion everywhere on, this was the inner side touching the aluminum at the back wall, and so this one is nice and smooth. Okay, so I'll take both apart. You'll see that this has failed. This allowed the wheel to move 0.5 millimeter, 1 millimeter. It had a play while it was mounted on the axle, and this bearing failure made steering vague and dangerous. Here we have the bearings, spacers and seals. I want to show you a few things on this seal here. This is how it looks like when it's cleaned up, and it's got a soft edge that should remain pliable. If it's hard and brittle, it's not going to seal. Okay? Also, it shouldn't have any chunks missing from it, just like this one is having a chunk missing from it, because the seal has a groove in its middle there, so the middle doesn't seal when it's in contact with the spacer, like so. Okay, so to prevent water from getting to the bearing, the seal's edges must be intact. So this is ready to be replaced. I don't have another one, so I will put it back on the bike cleaned as is, and I will rely on a rather liberal amount of grease to make it work in the amount of rain that might fall in the summer. Once this is in the wheel, it's easy to take it out. You just take a screwdriver and pop it out. When it's popped out, it's gonna be bent because there is a metal plate in it that sometimes shows up there. There's a little metal surface there that isn't coated with rubber because that's just how it got manufactured, just by sheer chance. Let me see this one. Yeah, this at the bottom here didn't get coated, so the metal is there exposed. It's okay, it works. So that's how these seals work. This one also has a chunk missing from it. That's why these seals really shouldn't be saved, but I didn't know what condition these would be in, so I'm gonna put them back on. I'm gonna be better off than without these. The spacers, or yeah, it will work in the summer. So this is how the spacers and these seals interact. Also, you can see that there's a little bit of clearance between the two of them, not a whole lot, as well as this soft edge that's also on the inside can be compressed quite a bit, can be overwhelmed quite easily with any amount of dirt. So that's why these seals need to be clean, intact, and their original size to keep out water effectively from getting to the bearings. And that's also why these spacers need to be in diameter, their original specs, without these corrosion deposit products here. So you can see the seal had was touching this here, and this is where the groove is in the seal. Okay, now I'm going to look inside these bearings. These ones are good to go for installing. Just grease it and that's that. So this is the one that's still smooth and running well, and this is the one that has this corrosion everywhere on it. That's good, so I can still identify it after it's been cleaned. Okay, so this is how the seal comes out, like so. And let's see, what's this big thing here? Something that's fried into a single chunk, and everything looks dried out on the inside. Let's take out the seal from the other side. This is how the sealed bearing looks like. So there, water will find a way, and does find a way. So this is pretty seized up there. Not good, and stuff is crumbly as it's falling out of it. I'm gonna wash it, soak it in some solvent for a few hours, and in the meanwhile I'll place the new bearings into the hub, and then we can look at this one and hear it now that it's removed from the wheel, and it's gonna make the same sound or louder noises than when it was mounted in the wheel and you listened to it the first time. Let's go at it. Well, just for a quick contrast, this one that did not fail moves really easily there. That's how it should be. And this is the one that seized / failed in a spectacular manner. Alright, so these are the bearings after soaking and cleaning. Remember, this was the seized up with the lots of rust on its perimeter, and this has only one rust spot that was transferred to the inside of the hub. So this is the condition of the one that did not seize up. Just listen to it. So it looks like happy bearing spinning. Yeah, it's making too much of a rattly sound. I'm going to hold it right next to the microphone, that it's rattly. Also, this is too much of a play this way, sideways. Listen to it sideways. it shouldn't be a rattle. It should be fitting, so it's quiet. Now, but just for contrast, this was the one that seized up. You can see the amount of rust on the outside that matches the imprints on the hub, and this was facing towards the spacer. So that's, oh, by the way, that's how the spacer and the bearing will interact. So just for contrast, look at this, or listen to this. Way more noisy. Look at this amount of play. Okay, so it's nearly falling apart. It's so bad on its own. Okay, so this has seized, this has failed. This is why the motorcycle's wheel was it was possible to move it on its axle without moving the steering. So this is really bad, potentially quite dangerous. Okay, so that's how it looks like. The bearing balls are rusty on the inside. These aren't the balls, this is the riveted cage that holds the balls together, but the balls, steel balls, are so rusty and dark and whatever that yeah, you don't see anything, any detail on that one. These ones are a little shinier. Yeah, maybe not in front of a white background. So this is how failed bearing sounds like and looks like. I'm ready to mount my new bearing, but before I do that, let me just show you the one that failed. So it was NTN brand. Here is the brand, and the model was 6005 is the bearing designation, and after that it says LU. Okay, so this is also 6005, but has different letters after it and is SKF brand. So, first things first, you have to put some lubricant in here to help this slide in more easily. Step 2, that's where this lubricant comes in. Step 2, find the tool that will drive the bearing. The bearing should be driven into place by exerting force on the outside of it, not on the inside of it. So find a socket or something, a piece of pipe, something that can be sacrificial, because the socket will deform under the hammer blows here where you hit it. You can try to hit a sacrificial brass or copper or some softer metal, softer than steel, and however some deformation may still be caused. Okay, so sacrificial piece of something, and it has to be sufficiently big enough but smaller than the bearing, so it doesn't get, the tool doesn't get stuck into the hub, okay, and doesn't harm, score or scratch the inside of the hub. Okay, so that's that. My tools are ready. Oh, do not forget, once you have the bearing placed into one side, don't forget to put the spacer bar in between the two bearings, okay? Because if you do, and you have to take out one of these bearings that you just placed, then the only way to remove a bearing is by hitting it on the inside bearing race, okay? If you hit it on the inside, okay, it's supposed to transfer loads this way, okay? An axle that's going through it is loading the bearing this way. When you are hitting it, you're loading the bearing this way. So, if you have to take out a bearing, the only way to take it out is to tap it on the inside of it. You might as well just buy a new one, okay, because it will be stressed sideways unreasonably. Okay, I know you're cornering and everything, but that's uniform and gradual loading, and tapping it out is a shock loading. Okay, so if you forget this, you're gonna be really sorry, because you're gonna need one more bearing. Now, I'm ready to do this. I had lunch, I had a washroom break, I have all the time for this. There is no phone calls, there is nothing. Nothing is more important than this. So that's a biggie amount of grease blob here that I placed inside, but I'm gonna spread it out evenly and nicely, and I'm gonna get rid of the excess, of course. You might have noticed that on the previous assembly it was both the bearings and the hub was noticeably lacking lubricant, so I'm adding extra or enough so this staining and this corrosion is minimized, if not eliminated. Now I've done something here that you really do not have to do. I have taken off the seal from this brand new bearing, and you can see how much grease is in it. If you want, for whatever reason, you can put more lubricant in it, but the lubricant that's in it is a specified amount, carefully measured, and then you can put the seal back on it, just like so. It snaps into place. It was taken out carefully, and it's placed back carefully, without bending it, without piercing it. There, so I seated it well. Okay, but the lubricant is special. Whatever I have is also special, but doesn't necessarily have the same physical and chemical properties as the one in it. These two may be incompatible with each other. In some cases I do choose to put extra lubricant in it, but not this time. This is top of the line bearing, and I'll be happy with it. Although these two lubricants could be compatible with each other, but I just trust the top of the line bearing that it's lubricated with the correct lubricant, with the correct quantity. So I'm going to transfer some of the lube on it from what's inside the hub just to the outside, just like so. There. And then place it into its tapping position there, and clean my hands. And especially how it started is critical. That's why I'll show you the beginning stages here. So what you do is you make sure that it's not going in sideways, okay, or in any way crooked. Really carefully position it, especially the first few taps, okay? I see that it's not balancing super straight, just like so, just like so, and then check it, make sure it's going in evenly on all sides. So rotate the wheel there, make sure that this distance is the same, uniform everywhere. I see it's a little higher there, so I'm gonna hit it towards that point a little more. Maybe I'm gonna hit it just directly this way. Yeah, just like so, because I really don't want to bust the hub. You see, it doesn't need a whole lot of force. It needs very little force, and then checking it all the time to make sure it's going in straight. Okay, it's not rocket science. It doesn't need a whole lot of noise, or doesn't make a whole lot of noise. There, so the kids can play in the background, whatever. Okay, that's how it's going. It's going fantastically well. I check very often like this, just to be 100% sure it's not going in crooked. I've reached the flush to the hub's rim point with the bearing, so it's going nicely and evenly. That's just a checkpoint, that's all there is to it. I'll keep going, just as before. One tap or two at a time. This is how it sounds like when it's driven to the final position of the bearing. There. Again, it's all the way in there, and I can verify this by looking at the grease on the other side. You're looking through the hub once more. On this side the bearing is yet to be installed. The spacer is going to take up this space. So if I zoom in a little bit in that direction, you can see the grease being squeezed out as the seal reached the inner surface of the hub. Somewhere there you can see the grease there as it's being squeezed out, as well as a little bit everywhere. Okay, so now at this point let's talk about preventing future corrosion. So the bearing gets wet from two sides. Okay, so rain falls and runs down on this side and makes the bearing wet here where the seal has failed. This one, okay, so the bearing gets wet from this side here, as well as it gets wet the hub here. You can see it's got these huge cutouts on it. Okay, these ones. So water gets in here as well, surrounds the spacer bar, which I just dropped here, and runs along the surface of the spacer bar, because there's a clearance between this hole here and the outside the spacer bar here, a generous clearance, you can see. So water is gonna coat this one, and it's gonna lead the water to the bearing, okay, to the inner side of the bearing. So I'm gonna place some grease to the end of this spacer and around the bearing here, okay, to prevent future corrosion going through the hub in this direction, as well as enough grease around the failed seal from this side to prevent corrosion again. So that's my plan of attack here. And that's how the same thing looks like when it's all greased up. So I'm gonna have to repeat it on the opposite side as well, because next thing is placing the spacer bar. That's how it looks like when it's lubricated from the inside. I tried to fill that gap as best as I could. Now I'm ready to place this bearing here. It doesn't matter which side of the bearing faces in or faces out. That has nothing to do with how the bearing functions. Back to the same tapping, cautiously, carefully. I ended up not using this one too much because I can see better when it's just one piece, and yeah, it doesn't hurt to have a few extra pieces of this and that handy. Yeah, a little bit, tap it over here on this side. Yeah, going as usual, going as it should. I just placed this old seal back on this side, and in order to do that I have filled this space with grease, and then tapping in the old seal is fairly straightforward. Let me show you how this looks like. Very, very simple. Fill this space with grease. While you're tapping, I forgot to mention this, make sure that the original seal that's covering the bearing doesn't get hit. So the size of your tapping socket has to match pretty much the outside diameter of the bearing, because if you bend the seal, if it's a little bit smaller and you bend the seal, that's not good either. Here is the old seal. It almost just goes in by hand, almost, and this is where this comes in. Maybe a hand wipe. Oh, do clean your tires and brake components free of grease. It's gonna help you a whole lot later when you're riding. There. But if it does get dirty, don't worry about it, just clean it with lacquer thinner. Yeah, not the tire though, so yeah, don't get anything greasy that shouldn't be greasy. There. So this is seated properly, and it's good to go for mounting on the bike. Back at the bike, I have lubricated the inside of the spacer, just like just like so, very straightforward. And when the axle goes, you can use the axle to align the spacer in the middle to make sure that the axle does go through, just like so. And if the axle is greasy in the middle, that doesn't hurt it, that actually helps with preventing corrosion on the axle, because you don't want to have the axle replaced on account of corrosion. So the next thing to do is, of course, lubricating these wheel spacers. But the important thing here is that the axle and the spacer inside, they have a clearance between the two of them. So this axle is not moving in the bearing, is pivoting in the bearing, and has this play between the spacer and the axle. So the axle is not tight in the spacer. That's important. The front axle tightening torque is 94 foot-pounds or 127 Newton meters.
So I picked it up right away.
There, that's tight. And I'm ready to check it for how it sounds like. These axle clamp bolts will have a torque of 15 foot-pounds of torque. These ones here at the front. Alright, let's see how much sound it makes. It shouldn't make any. Oh yeah. Run silent, run deep, baby. That's some bearing replacement well done.